Now let's go through the use cases. It will help you understand much better way where the validating admission controller comes into the picture. So first one is your pod security policy. Now pod security policy is commonly used as a validating admission controller. It enforces the security policies on the pod that we just discussed, right? So what this pod policy can do is you can actually write the policy in terms of host access, privilege escalation, and more. Now, what does this privilege escalation mean? It simply means that the application should not be having the access to the root level of permission inside the pod. This is what we call as privilege escalation. So we can ensure that any pod which is running in our cluster should not have privilege escalation. This type of, otherwise it will not be created, right? This is from a best security perspective. You can enforce this kind of policies. So again, this is where we are preventing the privilege escalation inside our cluster. Next is resource quota. Now resource quota is a validating admission controller which is going to enforce the consumption, right? You can limit on the basis of your quota how much CPU, how much memory resource in the namespace can be utilizing. If that resource tries to use more than those resources, then it would be exhausted, right? It will not create it, right? So resource quota is available as a resource directly, and you can go ahead and assign the quota to a namespace. This allows you to better manage the resources which you are having. Now resource quota is an example of a validating admission controller. What this means is, although you are directly creating it, but in the backend it's calling the validation admission controller. It checks the quota. If the quota is not breached, then it allows to create it. If the quota has been breached, then it will prevent from the creation. That is how the validating admission controller works. Next is network policies. Now network policies can be enforced using the validation admission controller to control the validating network access between the pod. So whether my pods are able to communicate using the particular network network access, that can be controlled using the validating admission controller. Now this is crucial for the microservices and the network segmentation within the cluster. Next is namespace admission policies. So validating the controllers, okay, can be used to define and enforce policies across the namespaces. So what we can do with this is that we can create the policies to follow the certain naming conventions and the resource limits in our organization. So what it's going to do is it's going to check whether the namespace that we are trying to create, it follows to our organization standards or not, right? So we can have certain aspect of monitoring it. We can have some prefixes, suffixes that is compulsory to be put in order to identify the purpose or the different organization standards that we are following. So these kind of admission policies we can create. If it does not cater to our organization policy, organization standards, naming convention, then we can actually prevent it. This is a much better way of making sure that your policies are enforced inside the Kubernetes, because once you create the Kubernetes, the resources are created much more faster way when you follow the GitOps approach than anyone is pushing. So making sure that these policies are enforced in nature goes along a long way for managing your overall infrastructure in a much more effective way, and limiting the loose points in your infrastructure which can be later come into the picture and avoid your overall availability and the manageability of the application, right? So that's where the validating admission controller plays a very important role. Next is custom validation. So we can go ahead and create the custom validation admission controllers to enforce organization specific policies. For example, we might want to use certain labels, annotation, naming conventions that align with our company standard, right? Suppose we want to add the organization unit, which is responsible for those pods, or a certain namespace. So those kind of actual validations and the policies we can write, which is going to make sure that these are catering, then only it allows the pod to be created. If those certain labels are missing or not available, then we actually prevent them from getting created. This might come useful in case the cost is a sensitive matter and you want to isolate on the basis of the labels that you have put in order to identify what how much the resource utilization is happening. In those cases, this custom validations will be very helpful for your case. Next is regulatory compliance. Now, this validating admission controller can be used to enforce the compliances. Now, these compliances are mostly used in the regulated industries, like that is of your finance, healthcare, right? So if you want to ensure that certain patient data is stored securely and that can be enforced by the controllers to validate this. Now in healthcare, basically the patient data is very critical, right? You have certain mechanism through which you are going to encrypt the data, then you are going to keep it on the nodes using the node affinity and those kind of rules, which are very highly regulated industry, this healthcare, right? So depending upon the what policy standards that you are following, you can ensure that the patient data is stored securely, it is encrypted, it is transported securely using certificate encryption, and those kind of policies you can implement it to from a regulatory compliance perspective. If one of the policy gets breaches, then it can prevent the data from being created, like the resource from being created inside the Kubernetes. Then you can guarantee that all the resources that are being created are following to your policies, right? This helps in the compliance perspective as well. Now next is resource limits and quota. Now controllers can enforce the limitation of the resource requests and limits the pod to prevent the overconsumption of the resources and guarantee resource availability. Again, so these kind of resource limits and quotas are going to help you to prevent breaching of or exhaustive utilization of the Kubernetes resources. So again, these are basically implemented with the help of the admission controllers itself. Next is label and annotation policies. You can use the validating controller to ensure that the specific labels and annotations are present in your resources, enabling easier monitoring, management, and so on. Okay, if those are not available, then it will prevent the resources from being created. Next is naming conventions. Controller can enforce your naming conventions, and it can help consistency across your organizational units and help in the easier management of the overall cluster administration. So again, conventions are very important because this is how you are going to follow, and based on these conventions you can write the different policies, monitoring, and those kind of stuff. So following the convention becomes very important. Then these admission controller is going to make sure that these are enforced when you are creating your resources, so it's going to guarantee it, right? That's how the naming conventions can be enforced using the admission controller. Next is custom checks. You can create custom validation rules for your cluster on your specific requirement. For example, you might want to enforce a policy to check if pods are using approved container images or not. Okay, so these type of custom checks. Not only this, there are more policies and the checks that you can introduce based on your requirement. So again, you can write any kind of policy that you want, and then you can enforce it, which is particularly useful for you, and it reduces the overall configuration, make sure that those standards are being followed, and it prevents the resources if those policies are not getting enforced, right? So this is how the admission controller works. Okay, now validating admission controllers. So if we have to sum up overall this validating admission controller, it is essential for ensuring the integrity and the security and compliance. This is all of them are very important. Integrity is from the data perspective, that the overall data should be have the data integrity well maintained. Then the security is the prime aspect, so we cannot compromise on the security part. And the compliances, if you are working in a regulatory industry, then this is very heavily used, and this can be easily applied, and you can guarantee the compliances in your Kubernetes cluster. This helps to prevent misconfiguration, resource abuse, potential security vulnerabilities by validating the resource against the predefined policies. That's why you will see that more and more people are moving towards the policy based approach, because again, when you follow this GitOps, you are creating on a very rapid scale, and then the more and more resources will be getting created. So you need to adhere that all your policies that you are following the best practices inside your Kubernetes. So it's going to apply those policies, and on basis of that you can take the action. Then you can guarantee that all the resources are following the policies inside your cluster before getting admitted or before getting created inside the cluster. So that's how admission controller is going to guarantee your integrity, security, and compliances inside your Kubernetes cluster.